Was the recommendation requirement to extend the pressure tips 10 meters from the building based on empirical experimentation? I'm not sure if it's you or Gary that talk about the 10-meter distance.
I talked about the 10 meters height, but not about the 10 meters pressure taps from the building. But this is something that we also used.
The 10-meter.
Yes, I haven't mentioned it, so I don't think the question is for me. But this is also something that we used.
But do you think that it's based on? Do you use it because it's based on
Yes.
an empirical experimentation? Yeah.
Yeah.
Okay. Thank you.
But maybe Gary should have a word about that.
Well, I couldn't get 10 meters from the building, and I think often there isn't a place 10 meters from the building, and I didn't recommend it. I don't recommend it. I mean, it might sometimes be the best place to measure, but I think from my experience, usually measuring close to the building is actually better.
Yeah, I think that's something different between Europe and the US, where you tend to measure close to the building in the US, while in Europe we tend to measure some distance away, most usually. But we will still need some more investigation, I think, to know.
Oh yeah, yeah. I should have mentioned that, you know, the measurements that I made are on one house, and I would like to repeat this on 50 randomly selected houses because, of course, when the wind is blowing on a building, the internal pressure change depends on where the leaks are with relation to what direction the wind is blowing. And generally, we think that when the wind blows on a house, it causes the pressure in the inside the building to go down a little bit. And so if you then sense the outdoor pressure on the leeward side, you also have a negative wind pressure coefficient there. And so the two both go down together, and then maybe that's good because they cancel. But another house might have the leaks on the windward side, and it will be pressurized, and then it will actually be worse if you're measuring on the leeward side of the building. So I think it depends on the building a lot, and it would be important to test a bunch of real buildings. And I think nobody's done this.
So we need another PhD for that, maybe.
Yep.
Other question, all of the statistics about wind are interesting, but what really matters is do wind speed or its fluctuation affect decision regarding ventilation? Have there been investigations into this variability? So this was for you. I just want to add something. I think it's not only about because I think, Dimitrios, you do have an answer for the end, but for the beginning, it's not only how it affects ventilation, but also when you have a mandatory target value, this is important to know how the wind affects the result of the measurement, and not only afterward how it affects ventilation. But I think, Dimitrios, you do have some information about the impact of wind fluctuation on ventilation, right?
Yeah, I agree with what you said, Valérie. I just probably have to make a comment about this, that the mean wind speed, the analysis based on mean wind speed, gives us quite important information. So it's not something that we should not trust. It's something that we should definitely use as a basis. This is, let's say, what I have seen both from previous investigations about infiltration, but also about the impact of wind on the air tightness test. However, the fluctuations seems to give, let's say, to give some explanations in many cases, or in some of the cases, if not many. And also the fact that the mean wind speed is something that we can rely on This doesn't mean that the formulations that they are in the standard, they are correct when it comes to this. So it's a different thing. So maybe statistically speaking, the mean wind speed is something we can trust. However, how this has been really imposed in the standard, it might be a bit problematic.
Okay. We have another question here.
Yeah.
How much did the QF50 vary? So that's the Q50 of the house you measured.
Yeah, and I don't have the number right now, but I think it was something like plus. I don't have, unfortunately, the answer right now, but I think it was at least plus minus 20% or something.
20%. Okay.
Yeah.
I think, yeah, we have also a reference to an article that is given in the chat by Targo Calamis, but also an investigation about the variation of QA50 depending on the envelope measurement positions. So, okay. There is also a question about, is the effect of air humidity considerable in the measurement of wind speed?
Well, this is not something that we did, but this is something that the ultrasonic anemometer, the specific one, takes into consideration. But it is not something that we do.
Okay, yeah. Okay, then we have a comment in Russian. I think it's mean, thanks a lot, very interesting. So, yeah. But please make your comments in English, that would be much easier for us. Okay, we do have still some time, so we can come back to questions that have come afterward from me and Gary. There were a question about, can you please reiterate when is it better to perform a one-point test as opposed to multi-point test? Well, the answer is it depends. If you want a value at 50 Pascal, if you only if your only parameter is the reliability of the test, then it's better to do just one-point test at 50 Pascal and avoid the linear regression. So if you want to estimate at 50 Pascal, whatever the wind speed, then it doesn't matter. It's just making a point, well, multi-point around 50 Pascal is probably better. Now, if you want to have the value of the air tightness at a lower pressure reference, such as 4 Pascal, as we do in France, or 10 Pascal, then, well, the limit is probably around 5 meters per second. Below 5 meters per second, then it's better to perform multi-point test and do the regression, weighted linear regression. And above 5 meters per second is probably better just to do a point around 50 Pascal and take a default N coefficient at 2/3 to extrapolate and estimate the air tightness at 4 or 10 Pascal. It's not necessarily exactly 5, it's probably between 3 and 6, as Ian Walker has said in his study, but, well, probably around the 4 to 5 Pascal. That's, we switch from one-point test to multi-point test. And then for Gary, I think we stopped here. The question was very specific, and what would be your reasoning? What should be the reason for the higher standard deviation at location 3 and 4, similar to location 7 and 8, versus the lower standard deviation at location 5 and 6 that are similar to location 1 and 2? So according to you, why do we have higher standard deviations at 3 and 4 than at 5 and 6? This is for Gary.
Sorry, I was muted. I don't know. let's see, I'm having to look at my chart to see where 3 and 4 and 5 and 6 are. So the higher standard deviations at 3 and 4. Well, 4 is on the windward side, so it's going to see more dynamic pressure there. There's more wind there, even where the building meets the ground. There's some wind there. And 3, yeah, 3 I would have thought would have had a lower standard deviation than it did, because it seems like it's in a fairly protected place, but it still had a fairly high standard deviation. And then versus the lower at 5 and 6. Yeah, 5 and 6, and actually it's interesting that 5 and 6, we have a 2 meters above the ground and then at the ground, where the standard deviation of the measurement at 2 meters above ground is lower than it is on the ground. But for 7 and 8, it's the reverse. The standard deviation at the ground was lower than in the air. And I don't know, I don't understand wind.
Okay, thank you. And then we will just take this last comment because we will be out of time after this. So I think it's back to the debate that we had before this comment say, I think the best reference point should be selected based on the best reference. So the most representative, I guess, place, not on the smallest standard deviation compared to wind fluctuation. The facade of the building is open to wind on different orientation and location, not depending on the selected point. The result should be compared to no wind measurement result to see which location represents the actual condition with least standard deviation. And I think, yeah, this is the same as this question about the impact of location on the result of the airtightness test. So maybe...
Yeah, unfortunately, I didn't have time to do multiple blower door tests for 30 days of pressure of wind pressure fluctuation measurements. I really had to narrow down my focus on just looking at the pressure fluctuations of the readings. But yeah, that's a good question. I would like to do that, and I think I disagree. It seems to me, if we're concerned about the uncertainty due to the zero flow pressure and due to the fluctuations in the zero flow pressure, then it is the standard deviation of the zero flow pressure that matters. And this is pretty much what Martin Prignon said in his paper at AIVC in Ghent, that the standard deviation of the zero flow pressures is a good estimate, gives you a good estimate of the uncertainty of the zero flow pressure. So I think that's true. And maybe I don't understand exactly the question. And actually, I was going to ask Dimitrios if he has any idea, if we don't have a fancy anemometer out to measure the wind speed, what the correlation he thinks might be between the standard deviation of the zero flow pressure measurements and the R squared of the regressions. Could we, in order to estimate the uncertainties in our final air tightness measurement, if we want to get an idea of how important fluctuations are, can we do that using the standard deviation of the zero flow measurement rather than going to the expense and trouble of setting up a 3D ultrasonic anemometer?
That's a very good recommendation, Gary, and certainly this is something that should be done. I think we don't know this unless we compare the like let's say that the advantage of having the anemometer is that you can go deep into details and then compare this with average data that you consider mean wind speed, or using even the 10 meters meteorological wind speed. So if you do the comparison between them, then you can really say how much actually it is worth or not.
I sure would like to see that comparison.
So do I. So I think we should talk about more
Okay.
about this more in the future. Yeah.
Yeah, I agree.
Well, this is a good conclusion and opening on perspectives on this study, as we see that the work on this subject is not finished and we still have some questions to answer.